We're going to continue on looking at numeration systems, and specifically we're going to look at numeration systems that are non-decimal, so that they're not base 10. We don't use these systems in practice or in the real world, but conceptually we want to understand these systems, because to understand our system right are better, and to experience some difficulties right here children have when learning our numeration system, it's very important for us to study non-decimal numeration systems. And so what we mean is that we're going to use different, the same symbols, but they're going to mean a different quantity, right? The word and the quantity are different. And so the first one we look at is what's called base 5 numerals. And what's going to happen is, think about, here's 17. Here's a quantity of 17, right? And there's your 17, and we write a little 10 because it's a base 10, 1, 10, and 7 ones. And so if we look at, and we wanted to convert that into a different, what we call a base 5 number system, you group the objects by powers of 5. So we're looking at this idea of base 5. Now we want to group these objects. You can see the 17 can be grouped in 3 groups of 5 and 2 ones. And so as you see that, how would we represent 3 groups of 5 and 2 ones? We represent it with the numeral 3, 2, and write a little 5 on the bottom. That 5 again signifies that we're in base 5. And we shouldn't say this equals 32 because we're not in the base 10 world. It really means 3 5s and 2 1s, and that's what we're looking at. And so here are some examples of base 5. I want to have a table here that you may want to copy down to your notes. These are the base 10 numbers. These are our first numerals, the first 10 numerals, right? Symbols we use for in base 10, 1 through 10. And so looking in base 5, 1 means 1, 2 means 2, 3 means 3, 4 means 4. What we're looking at really now is something's going to happen here. How do I write 5 in base 5? 5 is one group of 5 and 0 ones, and so that's what the number would be. 6 is one group of 5 and 1 1. And so with number system, which without writing it, what we're looking at on the number system, the place value for base 5, and you want to again get this down, but here's the place value for base 5. Instead of 1, 10s, hundreds, thousands, for base 5, the place values, the locations are 1s, 5s, 25s, 125. It's going up by powers of 5. So when we look at these examples here, you can see some base blocks. And you see 1, 2, 3, 4, and then 5 is 1, 0, a group of 5. This is 6, 7, 8, 9. And then this is 10, 2 groups of 5, and that's where it's 2, 0. 2, 4 in base 5 is equal to 14, right? And so you can see where that would be. And this is related to this question here. What comes after the numbers 2, 4 in base 5? The next number after 2, 4 is 3, 0. 2, 4. 2, 4 represents 2 5s and 4 1s. And then you add 1 to that, that turns into 15, and then 15 is really 3, 0 in base 5, because that's 3 groups of 5. So here are the next numbers for 2, 4. So what we have here is, if you look carefully, 2, 4 is 14, 3, 4 is 19, 3 5s and 4 1s. 4, 4 is 24 in base 10. The next numbers are 15, so in base 5 the next number is 3, 0. 20 is 4 5s and 0 1s. Those are the next numbers in base 5. What's the next number after 4, 4 in base 5? Well, 4, 4 is 24. 4 5s, 4 1s. The next number is 25. And so technically that's 5 5s and 0 1s, but in base 5, the next place value is 25. So the next number is one group of, what we have is one group of 25 and 0, 5, 0, 1s, and that's in base 5. Again, I know this is a difficult concept to kind of, you've never dealt with another base other than base 10. And so let's look at another example here. Here are some examples of converting from base 5 to base 10, looking at the pictures of the place values. Those are 1s, 5s, 25s, and then the next place value is 125. So you can see how those get converted into, you can see the expanded form for 132 is really 42. 125, 3 5s, 2 1s. So what's the value of 1, 2, 3 in base 5? It's 33 in base 10. 125, 2 5s. And again, important are these place values right here.